Okay, so we have two sets of data, set A and set B. These are the same as the first sets I gave you on the front page. 10, 20, 30, 40, 50. These are the scores of a 50-point test in section A of the class, and then these are the scores in section B of the class, right? All right, so for each, we will find the standard deviation. Here's the first thing you do. Find the mean, okay? And then number two, find the deviation from each data value. Now, the deviation is different from the standard deviation. There's only one standard deviation for each set, but there is a deviation for each of these values. Basically, it's the difference, okay? It's a difference between the mean and that number. So let me just, yeah, okay. So this will be the mean. This will be the value, each value, okay, minus the mean. All right, so in this case, we have already figured out mean for both A and B was 30. Okay, remember that? And let me just show you that just to remind you. At the beginning, we calculated this average. The mean for A was 30, mean for B was 30, because both of these sets, in both of these sets, the sum of the numbers was 150. All right, so 150 divided by 5, and so the mean was 30. Okay, so now what we will do is find the deviation. The deviation is defined as the value minus the mean. Remember, the mean is 30. 10 minus 30 is negative 20, right? So the deviation is just that number minus the mean. 20 minus 30 is negative 10. 30 minus 30 is 0. 40 minus 30 is 10. And 50 minus 30 is 20. So these are called the deviations. If you add up the total of all the deviations, you will get 0, okay? And this is just because the deviation is defined by the value minus the mean, and the mean is defined as the sum divided by the number of data values you have. It's not surprising that this total will always be equal to 0. That's what the mean does for us, okay? So that's the deviation. So adding up all the deviations really doesn't make sense, because you will get 0 every single time for every data set. That doesn't measure the spread or the variation, right? So what we will do is, instead of adding the deviations, we are going to add the deviations squared. So negative, now what happens when you square a negative number? Okay, yeah, it turns out to be a positive number. So this negative 20 is the distance between this value and the mean. But if you square that, it becomes positive 400. 100, I mean, negative 10 times negative 10 is 100. 0 squared is 0. 10 squared is 100. 20 squared is 400. So now you add up all of these deviations. Okay, if you add up these, it'll become, okay, 500, another 500, it's 1,000. And this deviation squared is an important number. Okay, now let me give you the formula for the standard deviation. The standard deviation, abbreviated SD, sometimes sigma, sometimes lowercase s, it is the sum of this thing we just talked about, deviation squared. Sum of the deviation squares, and then you divide this by not n, but n minus 1. And that's because we consider these to be, or these to be a sample of the entire population, okay? And yeah, it's very, very difficult to explain why you have, you divide this by n minus 1 as opposed to n, but just remember, this is what makes this standard deviation an unbiased estimator, technically speaking. And then you take the square root because you squared it first, okay? And this standard deviation is going to give you roughly how much each of these values are away from the mean, okay? So how far are these values away from the mean on the average? It's not technically the average, but that's what it measures. And so this describes, for that data set, the a good estimate of the spread or variation, all right? How spread out the values are. All right, so for this, I just found it's 1,000, right? So the top of this thing, the top of this fraction inside the square root is 1,000. And in this case, n is 5. We have 5 numbers, right? So what you can do here is a standard deviation can I write it here? I can certainly do that here. All right, in this case, the standard deviation for the data set A is the square root of 1,000 divided by 4. And it is the square root of 250. You take your calculator, you put 250, and you can put the square root. Some of your calculators may require you to put the square root first and then 250 and then close the parentheses, okay? You have to follow the syntax of your own calculator. But if you do this, you get 15.8, okay? And roughly speaking, this is saying each of these is away from the mean, right? And the average difference between the mean and these values is about 15.8. Okay, so 15.8 tells you the spread, the average spread, or the some sort of it's a measure of the variation of this data set A. Okay, so let's go to data set B. Remember here, the mean was also 30, right? So 20 minus 30 is negative 10. 25 minus 30 is negative 5. 30 minus 30 is 0, 35 minus 30 is 5, 40 minus 30 is 10. And then in the next column, we square each deviation. Negative 10, quantity squared is 100. What's negative 5 times negative 5? 25. 0, 5 squared is 25, and 10 squared is 100. If you add up all of these positive numbers, you get 250. So here, let's use the same color. For B, the standard deviation is the square root of 250 divided by 4, okay? And this comes out to be about 7.91, which is exactly half of this, right? And so that tells you, and by the way, you can tell that, you know, these are like half of the differences, okay? 30 is the average, right? These are like all 10 apart from each other, and these are like 5 apart from each other. So it sort of makes sense that the standard deviation here is half of the standard deviation here. Okay, so this standard deviation measures the variation of the data set. And it is the most useful one, as you will see, because this thing is extensively studied from a mathematical standpoint, and you can use this to describe all sorts of percentages, especially by based on this theorem called the central limit theorem. All right, but that's for the next lesson. Okay, now this will likely be on the exam, so make sure you study this. All right, I want you to come up with an example of 2 data sets, A and B, okay? And I want each data set to have 5 numbers such that A and B have the same mean but different median. Can you do that? Try to come up with A and B, all right? So in fact, I'm gonna give you an A, okay? Let's say A is 10, 20, 30, 40, 50, right? So the mean in this case is, of course, if you add up all these numbers, and by the way, the mean in this case is pretty obvious. I think you can tell the mean is 30. But if you add up all the numbers here, it's 150 divided by 5. So the mean value, or the mean for the data set A, is 30. Okay, can you come up with B? That has, B is another set consisting of 5 numbers, but the same mean and different median. So I want the mean of the numbers in B to be 30 also, but have a different median. See if you can do that. In this case, by the way, the median, because that's the middle value, is 30, right? So try to find or come up with a set B so that the mean is 30 and the median is not 30. All right, the second question is A and B have the same median, but different mean. All right, so let's say A is again 10, 20, 30, 40, 50. Again, the mean is 30 and the median is 30. But try to come up with another set B such that B has the median of 30, but the mean is something different. All right, and then number 3, I want you to come up with A and B. And in fact, I'm going to make sure A will stay the same. It doesn't have to be, but A is the same set, and I want you to come up with B, another data set, so that it has the same mean, that's 30, but A has a larger standard deviation. All right, so practice this, all of these, and see if you can come up with an example. Give yourself a few minutes. You can pause this video, and when you think you have the correct answer for each of these, okay, basically another number or another data set B, then you can come back and see if you get this right. And I'll try to explain. Of course, there's no one single answer for these, right? You're supposed to give me an example. But see if you can do this on your own, and then you can come back and finish the lesson. All right, so here we go. If you have to have the same mean, all right, if you have to have the same mean, that means the sum cannot change. The sum must still be 150. You see why? Because basically the mean is, see, I need to have 5 numbers, right? So to have the same mean of 30, I have to have the sum, which is 150, because the mean being the same means the sum divided by 5 has to be 30. So the sum has to be 150. So I have to come up with 5 numbers whose sum is 150, but with a different median. Okay, so how can I do that? Well, you know, I mean, it's pretty simple. I can do 10, 10, 10, 10. Now remember the sum has to be 150. So then the last one could be like 110, right? So it goes 1, 2, 3, 4, that's 40 plus 110 is 150. Notice here, in this case, the mean stays, you know, because it's 150 divided by 5, mean is 30. But what's the median of this new data set? It's 10, the middle one, right? So I have successfully created a different data set. So with consisting of 5 numbers, so that the mean is still 30, but the median is quite different. Now, of course, you can come up with all sorts of different ones. You can have 0, 0, 0, 0, 150. That would work. Okay. You can also do something like, I don't know. Let's see. 20, 20, 20, 20, and 70. Okay, that would add up to 150. Right. So there are many different correct answers here. All right. For number 2, I want A and B to have the same median. So the median means same number in the middle, right? So when you write these numbers in an ascending or descending order, I guess we have been using the ascending order from the lowest to the highest. As long as this number is 30, I'm okay. That's the same median. Different means. So let's change some of these things here, okay? I can do 10, 20, 30, 40. I can't have 50 here, but I can do 100, for instance, okay? That would guarantee that I will have a different mean because this is an outlier, right? And this number could be anything but 50, okay? Anything besides 50 would work here. If you want to put 1 trillion here, that's okay too, right? And in that case, the mean will be extremely different from 30, but that's okay too, right? As long as this number stays 30, let me just write that. This must be 30. If you're writing this in, you know, in an order. All right, so number 3, A and B have the same mean, 30, but A has a larger standard deviation. So in this, at this point, I need one more here. I need 5 numbers, you know, and I'm going to list them as usual from lowest to the highest. I have to have the same mean, so that means the sum has to be 150. So as long as I have the numbers, 5 numbers that add up to 150, and I have the smaller variance or variation, the smaller standard deviation, I'll be okay. The easiest way to do this is to start with 30, and you want the 30 to be sort of the average, right? And I have to make sure that they add up to 150, but smaller standard deviation than this. So what do I do? Well, I can use the one that I used before, right? I mean, this had a smaller standard deviation, or I can do this, 29, 28, 30, 31, 32, okay? And because these are all like 1 and 2 apart from each other, if you add them up, you do get 150. And that means the mean will stay as 30, but the standard deviation will be much smaller here. Okay, do you know how you find the standard deviation here? The standard deviation for this set is, you have 28, 29, 30, 31, 32, and the mean is 30, right? So if you do these calculations, you'll find the deviations, all the 5 deviations, -2, -1, 0, 1, 2. If you square these, you get 4, 1, 0, 1, 4. If you add them up, you get 10. So the standard deviation will be the square root of 10 divided by, remember, 5 numbers here, n is 5, but you subtract 1 from it, and you get this answer as your standard deviation. And by the way, that standard deviation for this set B is 1.581, which is much smaller, of course, than the standard deviation we calculated for A, which was 15.8. And this, again, indicates approximately, how closely are these numbers are spread out from the mean of 30. And so that should make sense. Okay, so that is our lesson. All right, and that's it for lesson number 13. And next time we'll go into 14. Now in 14, we'll make full use of what we just learned, the standard deviation, okay? And it turns out, as I said in the lecture, the standard deviation together with the mean gives us a very powerful tool, all right? And along with this thing called the central limit theorem, we'll be able to calculate things like the percentile of something that has a normal distribution. And so we'll be talking about that. And that, by the way, is the fundamental tool that people use to make big decisions. Corporations and governments and all sorts of entities and people use the standard normal distribution to make very important decisions. So that's next time in lesson number 14. All right, until then, I hope you'll have a great week. See you next time. Bye.